faraway hole in the ground, and a stick. That's all it takes to measure the size of the Earth. Somebody did it 1,700 years before anyone had even been around the Earth. Here's how. Ancient scholars already knew that the Earth was a sphere, but measuring that sphere seemed impossible.
You couldn't get off the Earth to measure it from outside, and nobody had ever been around it, and when people traveled, there was always more Earth to explore just beyond the horizon.
The Earth must have been huge.
But how huge? Around 240 BC, a guy named Eratosthenes figured it out. Here's what he did. Step 1, he found the distance between two Egyptian cities, Alexandria, where he lived, in the north, and Syene in the south. Step 2, he found a vertical pole in Alexandria. Step 3, at the exact moment of noon on the first day of summer, he measured the length of the shadow.
Wait, did I miss something? How can you tell the size of the Earth from a shadow? How does this work? Eratosthenes' method is built on some genius leaps of imagination.
Imagine you cut the sphere of the Earth in half, right through the center. The outside edge of that cut would be a circle, the Earth's circumference. Eratosthenes realized you didn't have to measure that circle directly if you knew two things. First, how far apart 2 points on the circumference were. And second, what part or fraction of the whole circumference that distance was. Then all you have to do is multiply the distance between those points by however many equal parts it would take to complete the circle. The distance was the simple part. If you cut the Earth so that your circumference went through both Alexandria and Syene, they'd both be on the circumference. In Eratosthenes' time, professional pacers measured distances like that by counting steps or the turns of a wheel. So Eratosthenes could just look up the distance. Alexandria and Syene were about 500 miles apart.
Okay, but what about the portion of the whole? How does that work? And what does it have to do with the shadow? That's where Eratosthenes' next leap of imagination comes in.
If you live in a sphere, down means toward the center. So if you stood in Alexandria and a friend stood in Syene, and you both pointed straight down, those two lines down would meet at the center of the Earth and outline a wedge, like the section of a grapefruit. To figure out how many Alexandria to Syene distances it took to complete the circumference, Eratosthenes needed to know that angle.
But he couldn't go to the center of the Earth to measure it. He'd need to measure it from the surface. But how?
One way would be to compare the angles of the up-down lines in Syene and Alexandria with some common reference, like some parallel lines that intersected both places.
It just so happened that Eratosthenes had just that. His reference was the sun.
Now, Eratosthenes knew that the sun was so far away that when its rays hit the Earth, they would be basically parallel. This is why he chose Syene as one of his two circumference points. He'd heard that there was a well in Syene where the sun would shine directly down to the bottom at noon on the first day of summer. In order for this to work, the sun's rays must be right on Syene's up-down line. On a flat Earth, Eratosthenes' pole in Alexandria would be parallel with those rays too, and it wouldn't cast a shadow at noon on the first day of summer. But because the Earth is curved, the sun's rays would be off from Alexandria's up-down line, and the pole would cast a shadow. Eratosthenes used the length of that shadow and the height of that pole to calculate the shadow's angle at just over 7 degrees.
But wait. How does that help? I thought we were trying to find an angle at the center of the Earth.
Here's the trick. The size of the angle between Alexandria's up and down pole and the incoming rays of the sun has to be the same angle as those up and down lines from Syene and Alexandria meeting in the center of the Earth. That little bit more than 7-degree angle was almost exactly 1/50th of 360 degrees. Eratosthenes hadn't just measured a shadow, he'd measured 1/50th of the Earth's circumference.
Boom!
So Eratosthenes multiplied the distance between Alexandria and Syene 50 times to complete the whole circumference. If we're right about the units that he was using, his calculation of Earth's circumference was about 25,000 miles, or 40,200 kilometers, and he was only off by less than 1%, with nothing more than a stick. From a single shadow, he measured the entire world.